Yeah, hi all. Um, Good to be here. Thanks. So first about me, I'm self-employed. I'm a lead developer at the Kiesraad, the Dutch Electoral Council. I've been developing software for a little over 20 years in various programming languages. Started in my teenage years, doing the PHP and other kind of things um, that I start out with. Um, I have a master's in embedded systems, so I've also done quite a bit of C programming in like low-level systems, and I have a bachelor's in computer science and engineering, both from TU Delft, not that far from here. And this is my GitHub handle if you want to find me. So what am I going to talk about today? I'm going to talk about elections in the Netherlands, introduce you for the people that are not from the Netherlands, introduce you what the election in the Netherlands looks like. I'm going to talk about the Dutch Electoral Council. I'm going to talk about the software that we're building for election results, which is called Abacus. And then I'm going to close off with why we chose Rust, how our development process looks like, and how Rust has been so far. So first, about Dutch elections. We vote on paper with huge paper ballots. There's boxes you can tick. You can tick one box to choose your candidate of your preference. For an election of the House of Parliament, this means there's about 1,100 candidates on there. So you can imagine it's like a bed sheet sized sheet where you can find your candidate, tick one box red with the red pencil as shown here, and then that's how you vote. You put it in a ballot box, and at the end of the day, it comes out. The stacks of paper get counted by hand, sorted out, sorted in piles for each political group. And then for that single polling station, the manual report gets written up. So you can see this on the right. For each candidate, by hand, numbers get written, how many votes every candidate has. And this goes on for many, many pages because, of course, we have those 1,100, 1,200 candidates. So you can imagine it's a lot of numbers. So to put that into perspective, the scale of our election process, we're a small country, only 10 million voters, still a lot of votes. To run those elections, they're organized by municipalities. We need about 100,000 volunteers. We have 10,000 polling stations. So in the Netherlands, it's always a polling station quite close to you, usually in a school or another public place. There's 342 municipal polling committees that add up the votes for every polling station in the country. So every municipality is responsible for its own polling stations. Those municipalities get grouped into 20 electoral districts, and every one of those districts have their own polling committee that adds up the votes from their municipalities. And then finally, everything from those 20 electoral districts gets added up at the central polling committee to get the results for the whole country. And you can imagine that's a lot of paperwork, it's a lot of work, lots of numbers. So we use software to add everything up without making too many mistakes. Of course, you could do it by hand, but I don't think it's going to be less error prone or it's not going to end well. So this is where the Electoral Council comes in. The Electoral Council determines election results. So they're the Central Electoral Committee. They provide advice and support, advice on how law is written, and they provision tools. They provide a toolbox for the paper process. So all those the form you saw, they provide that, provide a template for everyone to fill in, and more importantly, for this talk, they provide software. They provision software. They do that according to the core values, which are shown here. I'm not going to go through every single one of them, but for software, most important are integrity, transparency, and verifiability. So then, on to the software we're building. That's called Abacus. This is software to determine election results. So as Hugo already mentioned, we're not going to do anything about the paper process that's being done in the polling station. That's all still manual, it's all written by hand. But the day after the elections are held, those reports get entered into the computers in our software. This project is in-house and it's greenfield development. We're replacing another software system, but from scratch. We started this end of 23, so just over a year ago. So for what it does is those reports get entered twice, so that no mistakes are made. 2 people have to enter them independently. The software will calculate totals for every municipality, then gets added up for every district, and then for the whole country, and then for the whole country, the seats for the House of Parliament get apportioned, and of course for every other kind of election it's different, but in the end seats get assigned according to the number of votes for every candidate. Our software runs decentralized. Every polling committee has their own instance, which has no internet connection at all, completely air-gapped. This is what it looks like. This is how you enter those votes for every candidate. It's a clear interface, which we've tested with, it's designed by our user interface or user design expert. It's been tested with users, so it's all clear, it's easy to use. People only use this like once a year or something, so it needs to be like simple to use. This is what it looks like. So you enter the votes for every candidate here. And then there's usually a coordinator that coordinates the process of entering those votes. And he has this, or they have this nice election overview where they can see for every polling station what's happening, if there's any mistakes being made, and how far along in the process they are. Then onto our architecture. We kept it pretty simple, not to over-design with microservices and things. We have a front end, which is written in TypeScript and React. This front end is run on multiple computers, and they all connect to one central backend. The backend is written in Rust. That's why I'm here. And this backend then uses SQLite to store its data. Our backend is divided into several modules. Each module has its own kind of domain. So you can see there's a domain for the election management of the election data. There's a domain for the list of polling stations. There's a domain to do XML import and export, because that's the standard we use in the Netherlands. There's a domain to do PDF generation, to create reports from this software, etc., etc. I don't have to go over all of them. Then, why Rust? Well, first of all, it's open source, which is very important because it's required by law to build this software in a language that has an open source compiler available. Rust satisfies that property, so that's great. It's memory safe, which is super nice because we don't want any nasty bugs, especially because the software is decentralized and air-gapped, so we can't just send out a patch or like patch in production, because that would mean sending out the binary to everyone. It's strictly typed with a modern type system, which is also very pleasant to use, and it saves us from a lot of tricky bugs. The compiler will catch a lot. There's great tooling like Cargo to manage dependencies, manage libraries. There's great cross-platform support. By law, we have to run on at least an open source operating system, which in our case is Linux. Of course, Rust provides support for several other platforms. But not unimportant for us is that many municipalities do want to run on Windows, and Rust also compiles to Windows, so that's pleasant for them. And then finally, it's very easy to deploy. It compiles to a single binary, single executable, so there's no dependencies you have to install, no Python, no JVM, etc. Nothing else to manage. Then our development process and tools. The software is completely open source. It's on GitHub. It's licensed under the EU public license, which is kind of like GPL, but from the EU, and it's designed for software developed by governments. Contributions are welcome. We're out in the open. Visit us on the link and check out our code. We use GitHub Actions for CI. Every pull request gets analyzed, gets tested before it gets merged. We use static analysis using Clippy from day one, which is very, very helpful to prevent bugs and also to kind of match code styles. We use CodeColl for test coverage to test if all our unit tests, if all our code is tested by unit tests. We use Playwright for end-to-end testing. So what that does is it spins up a browser and it kind of simulates what a user would do to click through our application. We have test environments using ATES, which is a small project by Marlon from Tweede Golf, which means we can spin up test environments for every pull request on demand. Takes under a second. You can get your own test environment, which is very, very helpful to just check out what a new pull request is doing without having to check it out, compile it, etc., on your own machine. And finally, we use Figma for UX design, which has also been a great tool for us. Some of the crates we use the XM web framework web library from the Tokyo stack. We use Utopia to create OpenAPI specifications. Those OpenAPI specifications from the backend get translated into TypeScript types so that we can use them in our front end. We use SQLX for our database. SQLX provides compiler time checks for our SQL queries, also a very nice property. We use Types for PDF generation. Types is a great project. It's an alternative for LaTeX to create reports. We use QuickXML for XML import and export. And finally, we use Zerde for serializing and deserializing data, such as JSON and XML. And we use some other utility crates that I'm not going to mention, but you can find them in our GitHub repo. Finally, over 1 year in, what are our takeaways of using Rust? It's been very, very productive for us. We like it. It's a joy to use. It's also an attractive language to hire senior developers. Many senior developers are interested in Rust, which has been great for us. It was a bit of a uncertainty at the beginning, but it turned out to be a great choice in that sense. And we also find that media developers have no trouble learning Rust. They can do the Rust Links course, other resources. That's also been great. I don't have experience with junior developers because we just didn't hire them. Ecosystem has crates for almost everything. Many crates are stable. As Nico mentioned earlier, some have a single maintainer. Many only have a 0.x release, which doesn't matter, but it might look a bit like it's not ready for production use yet. So maybe something that can be improved. And we also found that crates for XML, for example, XML are lacking compared to other languages that have been invented around the time XML was like at its peak. So it's doable, but it's a bit less nice than you would see in other languages. And finally, you can see that there's limited availability of third-party code quality and architecture tooling. For other languages like Java, there's a lot of stuff in the ecosystem, for example, like tools like SonarQube to test your code quality. SonarQube has some beta availability of Rust analysis, but it mostly does the Clippy lints that we were already using. So there's also a bit of a gap there. But so far, everything has been great. We would definitely choose to use Rust again if we were to start this anew. So yeah, it's been great. That's it for today. You can find our GitHub repo there, and the second one is my personal GitHub handle if you want to contact me or find me somewhere around the conference. I'll be here all week. Thank you so much.
Right, Mark, thanks a lot. Shall we do one quick question?
Yeah, sure.
If there are any questions?
If there's any.
Yes, Matthias.
Thanks for the talk. I can certainly relate to the ecosystem lacking on XML grades specifically. Can you remember any bugs that you ran into in that area? Because I'm curious.
It's not so much bugs as that we have this XML schema definition, and in other languages you would just create code based on the XSD and you would use that. That's not available for us. We didn't find it. So one of our colleagues had to go through the XSD, manually analyze it, and then create structs and share the serializer attributes, which was a bit painful. So yeah, a bit of the issue is also that the XSD is like legacy. It's been it's gone through changes. It's a bit unwieldy at in some cases, but yeah, compared to other languages where you just put in a code generation, it's just a bit a lot more work. But the end result is still fine, and the Rust structs are super nice. So we did get there.